like employee ID and TNO will be composite primary key and add all attributes, which is not possible here. Why? Because we have works for relationship, another relationship. Okay? However, if you do not have such a relationship, employee and department is one-to-one only. It means it's just one-to-one. One-to-one means it's the same matching, right? But here, employee 1 million, department only 10 department. Even though there is just one-to-one matching, but option 2 is not a good choice. Okay, it depends also. You understand? But it's possible sometimes. Option 3 is create cross-related table relation. That means, why don't we create the many relationship? Then this is the employee, and this is the department. So this one has the SSN plus DNO start date and create the foreign key.
What's the third one?
Third one is create another new
Relation.
in the middle relation table.
What's the name of this?
You can make the, for example, manager.
Right.
Manager relation. Then create two foreign keys from here to here, here to here. Primary key of this one is combining employee and department. When can you select option 3? When you have bunch of attributes, you'd better create. Now most of the case not. So this one is most frequently used. Just a foreign key is enough for one-to-one relationship. The second is this one, in case you have bunch of information. Also, if you have application that access only manager, the transaction 1 is the accessing manager, transaction 2 accessing manager, transaction 3 accessing manager, you'd better separate. Okay? Option 2 is not, almost I never see such a thing. If that is true, that can be already addressed here, ER model. Okay? So that is the third step. Fourth step, one-to-many. In this example, I select the option 1, just create the foreign key and add attribute over here. One-to-many relationship. It's a simple. You can create foreign key. That's it. Okay, the foreign key works for employee, works for department. So department NO foreign key. Yes. Works department and project. Department controlled project. So this is the where's the project? This is a department. It's a dependent project. Yes. It's a control D number. So this one goes to this one. And what else? This one, supervisor. So supervisor SSN. Create foreign key to this. It's a simple. One-to-many is a simple. Next, this is also important. Many-to-many. Many-to-many is like this, and it has attributes. In case of many-to-many, you need to create relation in the middle, in between. Create the relation, then plus 2 foreign keys. Like this option. It's a similar approach. Where is many-to-many? Here, we have many-to-many. It can be here to here foreign key. It can be here to here foreign key because it's a many to many. Like for example, you are taking course. So student and course. How many courses do you take? Many courses. How many students each course have? Many. So many to many. How can you manage each student GPA? In the student relation? No, it has many. What about the course? Course has many GPA, the grade for student. So we'd better have the grading, grading relation. That's the in the middle, like this one. In this example, works on. Create this. What will be the key? Key is both this one and this one. Like the DNO, ESSN plus DNO will be key. So ESSN go to this, DNO go to department. Then what will be the attribute? Attribute is like this one, hours. This is many to many. Always many to many should create new table, new relation. Otherwise you cannot manage.
Work on between employee and department.
Employee and project. Works for is employee and department. It's a one to many. So we already did one to many, but this is many to many. Okay? Any other many to many? No, we do not have many to many. So this is okay. Then next step, multi-valued one. Do we have a multi-valued? Yes, location. We still do not handle multi-valued. Is there any way to manage the multi-valued column in terms of the relational database model? No. It's should be atomic. So we cannot handle the multiple location here. So to address that one, we need to create location table. Location of what? Is a department number and location name. So this will be primary key. That refer this one. That is the reason in real life system, even though your ER diagram is small, but later when you create the table, it's much bigger. Also in real life system, probably I mentioned when I joined the first project, it has more than 2,000 tables. Why? Actually, it has a lot of such a multi-value code. You know the code, parameter, like the 1 is good, 2 is bad, 3 is so-so. So this will be one table. Otherwise, you need to manage in your application, which is hard. So you need to create a very small size table, a lot, in your real life system because of this multi-valued restriction. So we can create this one. It's a multi-valued. You can create new relation with primary key plus foreign key. And alright, the last one is we do not have such a thing. So let's complete this one. Why don't you take a look at, and this one is the same as this one. Don't you think? I think I missed the project works on. I should be project. I think I'm sorry. This is not department. This should be project. Right? This is the same. So first time when I asked why don't you find the foreign key, it's a little bit hard. But it will not be hard if you start from ER model. Eventually, you can get such a thing. I know in your program language class or other courses, you already create something table because that is simple. So you, without considering such a step, you can create. However, in real life system, real life database model, at least 100 tables. It's not easy. It's not possible to create such a table without modeling. Sometimes you can do that, but later you will realize some data inconsistency. Also sometimes slow when you have many data, performance issues. So you should follow such a step. The one thing that I didn't mention is annotate. Supplier supply item to project. This is a typical example. Then, even though this one cannot be 3, they are not the same meaning. However, no way to represent this one directly, so we are going to use this one can be converted into this. Right? Then, no problem to convert this into relational model. This one is one to many, one to many, one to many, and each relation. That's it. So we are going to use this technique to convert an array. So for example, this one. So make one relation for supply, then create the 3 relationships. Then eventually, like this one is missing. S name go to here. Project name go to here. Part number go to here. That's it. That is the N array. Any problem? Any questions so far? So that's it. Then we have one more thing to do. That is extended super and subclass. Okay? That is sometimes the most difficult one. Let's see the example of like this. We have, this is a super and subclasses. It has the superclass for employee and job type, the secretary, technician, and engineer. And this time there are 4 options to map this. First option is, why don't we create one relation for each the class? This is one entity. So employee relation, employee table, secretary table, technician table, engineer table. So one relation for each class. So, for example, employee. Employee has SSN as the primary key. Then, for first name, middle name, initial, last name, and birth date, DOB, and address, and job time. Okay. Then, secretary. What will be the key of, primary key of a secretary?
The previous employee.
SSN, because inherit all the information about employee. So SSN. Do I need to create the name, SSN, birth date, address again? No, you don't have to do that. Instead, typing field and create the foreign key. So, foreign key. Similarly, technician.
Also have the
SSN and T grade. What about engineer. SSN, ENG type.
They
Key.
don't,
Don't forget to create the foreign key. Otherwise, this one, you don't know who he is. Right?
they don't have primary keys.
Primary key, primary key, primary key.
Yeah, by themselves. This will be foreign key for the.
But
security.
anyway, this is the primary key, but it refer to employee. It doesn't have to be only this one. Even primary can be referencing key. It doesn't matter. I never mentioned about there should be only the normal attribute. It can be key. But that depends on this. That is a characteristic of super and subclass. Actually, they are one entity. Right? Option 2. We don't need employee because as he mentioned, SSN is here, SSN is here, SSN is here. Why don't we convert one relation for only subclass? Subclass only. That means secretary. SSN, typing speed, plus first name, middle name initial, last name, DOB, address, and job type. Actually, you don't have to mention about the job type. It's already secretary, right? Doesn't matter. Technician. Primary key, SSN. And T grade. Same thing. First name, middle name initial, last name, DOB, and address, and job type. The last one, ENG, and engineer. It's the same thing. SSN, ENG type, and same. Do we need the foreign key? No, actually we don't need the foreign key. We cannot create a foreign key. It's a separate, individual. What is the difference?
The first one is better.
Better?
Or yeah.
It depends. Depends on what? Like if you if you design employee generalization. Generalization means first identify subclass. Most application or require access separately. Even though you generalize into employee, we don't need the employee. It's a secretary, separate. Engineer, separate. And technician, separate. At that time, this option is better. However, specialization, for example, employee, you identify employee. So we need the employee. Then specialize. Sometimes we access the employee, general common information, separate. And sometimes secretary, technician, engineer. You do better use this option. Okay? So it depends. Option 3. Why don't we create only one? Employee. Anyway, they are all employees, right? So social security number. Then first name, middle name initial, last name, and DOB, address. The problem is how to handle subclass. So this time we will use type of job. So job type. This should be job type. Then add typing speed. T grade. Engineer type. For example, if job type is what? Secretary. It will have typing speed 100 per minute. None. Okay? So job type is a technician. At the time, none. So technician, tech grade or T grade is the master level. And none. And if that is the engineer, null, and something great, like this way.
Multiple nulls.
But is it possible secretary and technician? No, it's not possible in option 3. So overlapping in case of overlapping, we cannot use this one. This is only for this joint. What if overlapping? So option 4 is for overlapping. It's the same thing. SSN, it's the same thing. Instead of job type, you can use secretary, yes or no. This is a Boolean. Yes, secretary, yes or no. Then this is the typing speed. Next, technician, yes or no. T grade. Then engineer, yes or no. So engineer type. So for example, I have employee, yes, secretary. Typing speed 100. Technician, yes. T grade is a master level. Engineer, yes or no? No. Is engineer type? No. Like this way. What if secretary no? It's a null. Technician yes, it's a master level. And no, none. Like this. It allows overlapping. Got it? So there are 4 different options. So it depends on your application and your requirement. Each one you need to select. So mostly this joint, option 3 is possible, but option 4 is overlapping. This one, if you access the common information separately and each subclass separately, option 1 is better, but it needs something foreign key. If they are, even though they are all employed, they are separately handled, you can go for option 2. There is no general rule which one is better. So you need to select person such a way. That's it. For example, vehicle based. Then this is the option 2, right? Is to create a 2 car and truck for subclass. This is employee. This is the third option. It has the one big table with the type of job. And this one, yes. This is the last option, slack. Manufacturer or not. And the purchase or not, B flat. Okay? This is one good example. At your home, why don't you try to understand? This one actually converted this. Then next class, I'm going to ask which options are selected. This is the answer of this, but we don't know which options are selected. So I'm going to ask, if you can answer, then I will give the extra point in the next class. Okay? So this one will be converted into this, but it has a lot of frequent subclasses. Each one has selected a different option. Okay? And last is mapping union type. I will slide it. Let me finish this one. The union type, we have multiple parents. So for parents, we have the different primary key. So we should have common, same primary key for parent superclass. That is called surrogate key. So we need to create a surrogate key, in this case owner ID. So owner ID left for this one, owner ID left for this one, owner ID left for this one. Similarly, vehicle ID left for this, vehicle owner ID, vehicle ID, car and truck left for this one. We need to create a common. Same key is an additional key for to combine all owner. Because they are owner, right? They are car. That is the union type. One more quiz. This is a real take-home quiz. It may take a time, probably. It's a 2 questions.
What is the due for
This is due on Wednesday, next Friday. Okay? The next Friday. This is due, but the other should be done on Monday, especially the quiz 4. Okay, quiz 4 is easy.
Friday.
If you already did, you can submit it. Quiz 4. Any other question? Then next class we will briefly review this one with the quiz, okay, and question. Then next class we will have the start how to access such a relational database schema. Okay, that will be basis, fundamental of SQL. Okay, thank you so much for your attending the makeup class. So we will continue next week, and we will have another makeup next Friday. I think this room is better than
Yeah.
that room. But
We could come
unfortunately,
here every day. We can.
probably not. I will check if this room